is what are the different solutions are available for the Kubernetes. So development or testing environment, that is learning environment or development environment, immediately, I mean, they don't want to struggle with that all these master node and worker nodes, right? For the developers point of view or learning point of view, yes, you can use it, the single hosted machine related cluster setup. But the production environment which are looking about it, multi-node setup, and that's a master node and worker node setup required. But here we have the possible cases. Is it on-premises data center or is it a cloud solution point of view? Yes, which we need to think it on the basis of the client requirement. But a development or testing environment, what is the solution we have is Minikube. Yes, a single hosted machine. That means you can quickly launch that cluster. The master node itself, we can use it as a worker node, where you don't have that two or more machines, as actually one is master and as well as another like a worker node, right? Worker node to run that Docker containers, master node to manage it. But if you use a Minikube, especially on the Windows or like single hosted machines, quickly to develop it or learn it, yes, Minikube is a solution. On the Windows also you can set up that and you can work with that Kubernetes or you can learn the Kubernetes. That is single hosted solution. But on premises, if you would like to set up with the master node and worker node, high availability with all these features, then kubeadmin is the best utility. Yeah, kubeadmin is the main utility which is supporting about it. You can take it like you can use it even Vagrant also. Vagrant, using Vagrant multiple machines you can launch it. Two or three CentOS systems, and one system you can use it as a master, and two systems as like that's like as a worker nodes we can configure it. But what is the tool that you can use it to set up that complete Kubernetes cluster on virtual machine is, that is kubeadmin, we can use it. But cloud ready-made solutions, that is AWS point of view, we have Kops utility, we can use it, Kubernetes operations, or which we have those, that is EKS, that is a Kubernetes ready-made solution, the managed solution. Just to give some inputs, the AWS AWS team is going to take care of that Kubernetes management. And master node, we don't have any activities. Master node is managing by the AWS team. You need to just take care about it or log into that worker node only. That means any patches or any backups or recoveries and everything AWS will take care of it. That is AWS managed service case. But if you would like to control it, master nodes and worker nodes with less cost of that, then Kops is the one solution where we can define it master nodes and we can define it worker nodes. We have the control everything. That is about our custom managed Kubernetes solution, that is Kops. And Azure point of view, on Azure, like we have that AKS, Azure Kubernetes service, and Google Cloud point of view, on the Google we have the GKS, the Google Kubernetes service. Yeah, there are the many services on the base of the cloud, but only setup is the different. Yeah, initial setup is the different, but once that's like a Kubernetes setup is ready, application oriented activities, that is like a container management activities, on this Kubernetes point of whether you are using the Minikube or kubeadmin or AWS or any cloud solution, that is same. But only initial setting up that as a interfaces point of view or a cloud solutions point of view, we have the different mechanisms. But once the cluster is ready and you are connecting to the cluster, is nothing but once it is connected to the cluster, whether that is EKS or AKS or GKS or kubeadmin, that is application side resources management is the same thing. That is a beauty which we have. Okay, so fine, let's look into that. We need to have the cluster setting up this, right? Yes, let's go for setting up that Kubernetes cluster. I'm going to give that demonstration with the master node and worker nodes point of view. Yeah, we can use it Minikube also, simple solution. On about our Windows itself, we can set up that if the virtual box is installed. But I'm going to use it Kops on AWS with the master node. How do we set up? and how do we define that worker nodes, and yeah, then like going for that one by one configurations of that application side. That's voting application, whatever we discussed. Then how do you go for that deploying that images, the Docker images which we discussed on the Docker Compose or Docker? How do you work with that Kubernetes cluster on Kops? Yeah, we are going to talk at that here the Kops. But whenever we go to that like next advanced some classes, there you will be having about it EK solution. We have the demonstration Minikube solution, we have the demonstration kubeadmin solution, because the different clients, the on the base of their requirement they come up with that. Do you know that kubeadmin utility to set up the Kubernetes? Do you know that EKS to set up the Kubernetes cluster? But only setting up that on the base of the client requirement, that is going to change it. But once Kubernetes cluster is ready, what are the activities we are doing that application side? That is, we have, yeah, the next app resources. This is important. But before going to work with this app resources, you need to have a cluster setup. This is until that we are talking that once cluster is ready, next this one whatever you are going to talk it, whether the cluster is running on AWS or GKS or AKS, doesn't matter that. Okay, I'm going to use it that Kops utility to set up that. Let's have the demonstration of this how do we set up that Kubernetes cluster using Kops. You can find that the documentation from here. Like as a professional environment, and so installing Kubernetes, the deployment solution Kops. Yeah, so it is automated provisioning system. So there's a just you need to define some properties, and yeah, you need to have it. I mean, some like properties defined in that for the Kops, and the remaining it is going to take care of that. Yeah, so the fully automated installation and the DNS is required. Yeah, some prerequisites, but anyway, we'll come back. What are the things? How do you do that? Yeah, what you need to have this before you begin is you must have kubectl installed, and Kops is the utility that has to be. What is the kubectl? Kubectl is the client, right, to connect to the cluster and to apply the configuration changes. Yes, that utility is required. And Kops we are using to set up the cluster. But once the cluster has been set up or defined, then we use the kubectl to connect to the cluster and to deploy application resources. And we need to have AWS account, and fine, yeah, there are all the things. Yeah, so there are the 5 steps we have. Install Kops. Do you want to have it on the Mac OS or the Linux? We are going to use the Linux. Yes, so there are some commands they have given we need to go for. Then Route 53 we need to set up that, and then S3 bucket is required to store the cluster state, and finally create a cluster and validate the cluster or update the cluster. Yeah, so all these steps in our GitLab I have given that. If you go to that GitLab, so it has been given the step-by-step documentation. Yeah, so the Kubernetes resources, you can go to this repository, Kubernetes resources, and here you can find it, the complete, I mean, Kubernetes on AWS using Kops, so the complete step-by-step. So that's the more detail, but in Kubernetes documentation 5 steps it is showing, but see that's how many steps we have, the one by one doing that. Yeah, let me go for, so that is I'm going to take this one Linux EC2 instance, where we need to set up Kops utility, where we need to have the kubectl utility on that host. Yes, already we have the Docker host, right? This is the Docker host. I'm using the same one, or you can take that new machine as a separate Kops utility, or you can use it that EC2 instance. But anyway, that's fine. I'm going to use it that this EC2 instance as a Kops utility. Now I'm going to just changing this one as Kops. So why we are calling this Kops is we set up the Kops utility on this machine to manage the cluster. That is cluster creation or cluster updation, and how many march nodes required, how many worker nodes required. That's everything we can control it from here. Yeah, I'm going to use this machine as a Kops. Let's launch that one EC2 instance. That is Linux AMI, more enough. About our RNS Tech AMI, you can use it. And let me connect to this. Let me connect to this. Okay, this system, instead of calling that a Docker, I'm going to call this one as, yes, I just renamed that as Kops utility. Okay, fine. Now we have taken one EC2 instance. And now what are the things that is required? So now we are going to create a Kubernetes cluster using Kops utility, right? But to create a Kubernetes cluster on this node, yeah, this node should have, that is like I mean some S3 buckets we are going to create it, or Route 53. There are the permissions required. That means, so what we are trying to do this is, so we need to create and attach one IAM role to that EC2 instance, and that IAM role should have these permissions like S3, EC2, VPC, Route 53, auto scaling, because like whenever it is creating the cluster, it is going to use it all these resources, Kops. So on which machine the Kops utility you are going to install it and Kops you are going to use it, that machine should have the permissions to set up all these resources. So now we are taking that EC2, and using that EC2 we are going to create it, I mean all these the resources within that AWS. So that EC2 should have the role with all these permissions. That means we need to create a role. So now let me go to that, the role creation. For which service purpose we need to create a role now? EC2 point of view. Yes, we need to create a role. I'm going to create a role for the EC2 instance point of view. But what are the permissions required? S3, Route 53. So these are all the permissions required. Even internal to some more also. But instead of that, assign this one administrator access. Now for this EC2, I'm going to give that administrator access. So what are the resources that is required to create a Kubernetes cluster using Kops? That's all that it is going to take care of it. Or otherwise, you need to find it one by one, and you need to assign the permission. Sometimes cluster will get failure because of the permission denied. Okay, let me use it administrator access. And this is name as the Kops role, right? Kops ECT role. Yeah, now we are trusted entity is about our EC2, and we are given the permission that is administrator. That means from this EC2, you can manage that all the resources which are required for the Kubernetes. Let me give me the name of this one as this is Kops EC2 role. Already exist. Maybe there's already there. So what is the batch number? Let me try to give that P30 something. Yeah, now this role we need to attach to that EC2 instance which we are going to use it for the Kops. Yes, role has been created. And now this role we need to attach to the EC2, right? Let's go back to that EC2. How do we attach the role to the EC2 instance? Yeah, so this is a Kops machine. To this Kops machine, now that role is required. So let's go to the actions. And in the security section, the modify IAM role. Now what is the role? So let's try to check it. B30, right? Yeah, so Kops EC2 role for the B30 we have created. This is the role I am assigning that. This role is I have the permissions administrator. Now this EC2 instance is going to get it administrator privileges to create all AWS resources. Yes, that is indirectly we are giving authorization to this EC2 instance as administrator privileges. Yeah, that is the first and foremost step. The Kops need permissions to access it. That is a create and attach IAM role to the EC2 instance. Yeah, that's way hard done. Next, we need to install the Kops utility on EC2 instance. Even you can refer to this same documentation from here also. Yeah, the first fully, do you see this AWS account and generate IAM keys and configure them? Yes, and we need to have that the adequate permissions for that. That's we have done with the IAM. With that IAM, we have attached to that EC2 instance. Next one is install Kops. Yes, these are all the commands which we have. These commands we need to run it. So the same commands I have given here. So just take it and run it on that EC2 instance. Now let me just take it first. Install Kops on EC2. I'm going to execute these commands. These commands you can get it from the Kubernetes documentation. Just take it and run it. Nothing big deal on this. Let me go for commands not copied. I'm just copying once again. Yeah, so it is done. Downloaded that Kops file. So this is the file which is trying to downloading, and it is setting the executable permissions, and it is moving this Kops utility to the user local bin as a Kops. Now you can check it. Kops you are able to run it or not. Let me check it. Kops is installed or not. Yes, we are able to run this command, but I have so if not required here. Yes, so if you are able to run this Kops command is nothing but the Kops is ready. And which version, latest one which we got it is 1.020. Kubernetes, what is the latest version which is available? 1.21. Still that is which we can say that is in the process, but like as the latest release which we have this is 1.20 stable version. Yeah, we got that Kops, but Kops is not enough. Then what we need to have it is the next thing is we need to install the kubectl. Kubectl is the client to connect to the Kubernetes cluster to manage the app resources. But how do we set up the kubectl? That is also same thing. Download it and set the executable permissions and add to the path variable. So these three commands, let me copy it and let me go to that instance and run the commands. Yeah, that is downloaded and it has been set up executable permissions and it has been added to the user local bin. User local bin is nothing but path variable, right? Yeah, now let's check it kubectl whether you are able to run it or not. How to check it the kubectl is installed or not? Yes, kubectl version. But what we are saying that kubectl is the client to connect to the cluster and to manage that all application resources. But here you see that whenever we run the kubectl version, it is given the two versions. One is client version. What is the client version which you have is 1.21. Kops is still it is we got it 2.0 only, latest stable one. Kops, that is a cluster to configure it. But client we got it, kubectl we got it 1.21. No issues on that. Client we can have the same version or a higher version, no issues. But the Kubernetes version, what is the version we are going to set up? This is 1.20. That is the latest one which has been downloaded, the Kops utility. But kubectl is downloaded, the latest one 1.21, and that is a client version. But you see that one exception we got it here. The connection to the server was refused due to specify the right host or port. That means still the kubectl is not connected to the Kubernetes cluster. So what is the meaning of that means? Whenever we are understanding the Kubernetes architecture, yes, kubectl now we have set up this, right? We have downloaded and we have installed. Kubectl is the client which is connecting to the cluster. Cluster is the server. But cluster we didn't create it, right? Cluster we didn't create it. That's why whenever we check it here, the version, now it is showing that only client version, but server is still not connected. That means we didn't create a cluster. Once a cluster is created and once it is ready, then we'll see that server version also. Still, the kubectl is not connected to any Kubernetes cluster. We are just installing the tools. Yeah, now the Kops ready and as well as kubectl is ready. But kubectl only client is ready, but it is not connected to that any Kubernetes cluster. Yeah, once Kubernetes cluster is created and if it is successfully connected, then if you run it this command, you see the server version also. But now the server is saying that server is refused. That means it is not able to connect to any cluster. Fine. Anyway, that's will come back later. After configuring the Kubernetes cluster, we see the kubectl with the server connectivity also. Yeah, are you following the point? So what we have done so far, if you just observe that, so we have taken EC2 instance and we have created one IAM role with administrator privileges and we have attached that IAM rule to the EC2 instance. That is the first part. Then on the EC2 instance, we would like to set up that Kops utility and kubectl. Kops, why it is? Kops, what is the need of it? That is to create a cluster, it is going to help with that. Or to to create a cluster or to update the cluster, how many nodes required, how many master node capacity, worker node capacity, everything that's we set up that by using Kops. But once you use the Kops and you set the Kubernetes cluster, but how to connect to the Kubernetes cluster to manage that application resources, that is containers, how to deploy it or how to manage it, that is kubectl. Yeah, these two utilities that's we have set up now. Yeah, but what is the next one is after kubectl, what are the Kubernetes cluster we are creating about it? All that Kubernetes cluster information where it is storing, that stores in etcd, right? But etcd, if you store it in the local system, if that is got failed, then we will be losing that entire cluster or not. Yeah, we never stored that complete configuration information of that the cluster state in the local system. We store it in some S3 bucket. Yes, for that, create one S3 bucket. Yeah, create S3 bucket in AWS. Yes, S3 bucket is used by the Kubernetes to persistent cluster state. Yes, what are the current state of the cluster we have? It is like a snapshot. A snapshot of the cluster. We are storing everything in stuff in the local system. We are going to store it in the Kubernetes. AWS S3 bucket. Yes, for that, create one S3, that is a create bucket, and but make sure about it the bucket name and cluster name next to whatever we are going to create it. The cluster name and bucket name, make sure it that is same. Make sure you choose the bucket name that is unique across all about our AWS account. That's fine. And as a standards point of view, the cluster name, whatever we are going to create it, the same with the same name we go for the creating a bucket name as well as. And in which region you are doing that cluster. So that region also we need to specify that. Which region we are using, that is US East to 1. Fine. So now I'm going to use this command. So to create a cluster within the region, but cluster name what I'm going to give this is rnsec.in.kubernetes, fine, but about our batch number is b30, right? b30.rnsec.in dot kubernetes. K8s is nothing but Kubernetes shortcut form. I'm just going to use it this bucket to create it. Yeah, so bucket has been created, and you can verify the AWS S3 ls. So to view that list of all the buckets, yes, has it been created? Yeah, b30. Yes, this is the bucket which has been created. Fine. Next, what is that? So we're doing that one by one, all the steps which are required for that. So bucket has been created, but that is not enough. Next, go for that. All the nodes, whatever we are going to use it within the Kubernetes cluster, they should not have the dependency on IP addresses. Instead of using that IP addresses, but how they can communicate with that internal heartbeats point of view, the checking about it like a master and worker node health checkups point of view is we need to configure one DNS name resolver. That means we need to set up that Route 53 one DNS name for this cluster, and all the cluster nodes are going to use it this DNS name resolver to have it the communications between all the master and worker nodes with the name based, host name based instead of IP addresses based. Yeah, all the clusters should have the same heartbeat, right? They should have the communication. So the DNS lookup, whatever we are going to create that, the cluster name with the same name will go for that DNS name creation, one Route 53 DNS name, to have it all the nodes in the cluster. The communications on the base of that, on the base of the DNS name itself. For that, what we need to do this is we need to create one hosted zone within the Route 53. Already hosted zone we are doing this, right, for public domain. If you remember that, how those DNS names are helping about it to have the communication between the client to the backend resources, that is domain naming mapping. Like that, we need to create one private hosted zone. Here we are going to use it this DNS only internal, not for public. So go to that Route 53 and choose name, like a cluster name, whatever you prefer that. The cluster name point of view is create one Route 53 DNS one create hosted zone within the Route 53, but it should be as a private one, not the public one. This is only within that VPC we are going to use it to have that all the communications of the nodes within the cluster. Let me do that activity. I'm going to that Route 53. So we need to create one hosted zone. Yes, I'm going to create that the hosted zone as for about our batch point of view B30 rnstech dot in. Yeah, the cluster name also is the same. I'm going to use it. Then the cluster, within the cluster, what all the nodes are going to use it? All the nodes are going to communicate with the master and agents. It is going to identify the nodes automatically with this DNS name. Yeah, this is a domain name. I'm going to use it for about our batch point of view. But this is the public one or private one. We are not going to go the public. Public is about our Route 53, which we discussed before that, application hosting. But now here we are using that Kubernetes internal to run it. This is a private hosted zone. But in which VPC? Private hosted zone you are defining is nothing but VPC you need to define it. In which VPC? Region is, we are using the switch region. North Virginia, right? Yeah, US East 1. So in this North Virginia, what is the VPC? So default VPC, or if you have this custom VPC, the VPC. Now within that VPC, what are the nodes we are launching? That all the nodes we are trying to communicate with this DNS name. So the cluster, next whatever the cluster we are going to create it within this region, within this VPC we are going to create it. Within the VPC, all the nodes, the cluster nodes are going to automatically communicating with this DNS name. Yeah, that's point of view, this hosted zone we need to create it at. Yeah, create a private hosted zone in AWS Route 53 with a cluster name. Next, configure some environment variables. Why do we need that environment variables? Yeah, about the cluster name or about S3 bucket name. So next in some commands we need to use it that. But instead of typing that each and every time, what we can do this is we can add cluster name, that is a Kops cluster name. What is the cluster name we are going to use it? B30 rnstech.in. And Kops state store. State store, where we are storing about it? This is the bucket we have created, right? This bucket URL. So these two things we are going to add it, Kops state store, Kops cluster name, because whenever we are creating a cluster using the Kops, it is going to use it state where do you want to store it, and what is the name that you want to create for a cluster. That name and bucket names. So instead of passing that's here, what we are going to do that we are just creating that these two environment variables. Just using yeah, so we are just creating what is that cluster name is b30.rnstech.in, and what is the s3 bucket which are created? Yes, s3 column b30 rnstech.in dot kubernetes. These two environment variables we would like to add it in the bash rc file. Let me go back to that, or otherwise you need to use it each and every time typing that to complete all this string. Instead of that, what we are doing this, we are adding to the bash rc. Yeah, export the Kops cluster name and state store. State store where you would like to store it, that is an S3 bucket. That S3 bucket URL which we have created already. And let's source this. Fine. Now if we check it environment variables, yes, Kops state store is this is the URL, and Kops cluster name is this the name we are going to use at that. So during cluster creation time. Here, let's move to the next step. That is a create SH key pair. Why do we need to create a key pair? What are the master nodes and worker nodes which are creating that? You need to have that communication, or you need to log into those systems or not. If you'd like to log into that from the Kops system, Kops is the source system. Then what are the master node? What are like worker nodes which are creating? If you'd like to log into the system, you need to have that passwordless logins. The passwordless logins to have it, yes, you need to have the keys, the public key and the private key. That point of view, we are going to generate keys which is getting used by the Kops, and Kops is going to take care of that, copying that public key to all the worker nodes and the master node which is launching that. Yes, we have created the keys which are required. I just run the sh keys and then there's nothing more here. But we know that's already keys usage, right? I'm not going to talk it separately. Yeah, now let's go for that cluster definition, defining that. Yes, this is the command, there are all arguments, or you can check it Kops help to get it list of all the operations. But let's go for that. Now customizing this command. Yeah, this is a command which you are going to use it to create a cluster. But how to create a cluster? What are the options? Yes, one, yeah, Kops create cluster, and one of the argument which you have is a state file. Where the state file is, do you want to store it? That's already we have added environment variable. That environment variable we are passing here. Fine, that is one argument. Now what is the next argument? How many worker nodes that do we need it for this cluster? Yes, that is node count is the property. So if you define this four worker nodes, it is going to create it. If you define the 5, that is on the basis of the requirement, you can mention it. The number of worker nodes which are required for the cluster. That is we are defining the 2. Fine. And what is the master node capacity? We have the T2 micro, T2 nano, that's a type of instance, right? Yes, on the basis of the master node capacity, what is the capacity that is required? Master size, we are going to take it the T2 small. T2 small is a cost oriented. Please make sure that. Then you can try with that T2 micro as a free tier eligibility. But sometimes you'll be having that slowness. But have the patience. But I'm going to use it as a demonstration required, right? That's point of I'm going to use the T2 small. But use that T2 micro whenever you are creating a cluster. Then it will be in the free tier of that EC2 instance. Yeah, the master node capacity. And then worker node capacity. Yes, T2 small here also. I'm using for even worker nodes also. T2 small kind of that EC2 instances we are launching that. That means RAM size around 2 GB which will be having. And in which zones that you want to launch it? Availability zones as a high availability point of view. Now it is going to launch the 2 worker nodes, right? But these 2 worker nodes, are you going to launch it in one availability zone or multiple availability zones? Multiple availability zones. But what about those multiple availability zones? Yes, here you can define that. What are the availability zones that is required to launch the EC2 instances? Those availability zones names. Where do we get it that all the availability zones? If you go to that VPC, you can get it right of that the region. If you go to the VPC section, all the subnets which we have. Yeah, so there are all the availability zones which are available. 1A, 1B, 1C, 1E, 1D, 1F. Because North Virginia is a big one. They have given almost 6 availability zone. They have given that. Yes, where do you want to span it? That availability zones you can specify that in that command. What are the worker nodes you are launching? That's worker nodes. Yeah, the subnets we are launching. We would like to launch it 1A and 1B. Yeah, that's enough. And then name of the cluster. Yes, what is the name? Already we have defined that variable name for this. Yes, the Kops cluster name. I'm going to use it the same variable name. And finally, so DNS is the private. We have created, right, private DNS name. And how many master nodes? Even that master nodes also we can define it. How many master nodes count that do you need it that? Yeah, one is enough. We don't need that more than that. But even the master nodes also, if you need the high availability, one master node got failed. Another master node has the communication with the worker nodes. Yes, even that's also you can control it with the master node count. Yeah, these are all the properties which are going to helpful to create a cluster. Let me run this command and let's see this whether it is going to create a cluster or not. Yeah, create cluster state. Yes, we are storing that complete state in that AWS S3, and two worker nodes and one master node we are defining, which are having the size as T2 small. And in the two different availability zones, we are planning to launch it with the cluster name and within the DNS private network. Yeah, so now you see that. So create cluster, whenever we do that, Kops create cluster, it is very fast, right? Very fast. And is it created cluster now? No, it is not created. It is just verified that the complete configuration which is required for the cluster. You see, this cluster configuration has been created. Suppose if you go back to the S3, where we are storing that information of that complete cluster, go to the S3 bucket. Yeah, so this is a bucket with a TRNS stack, and yes, it is created one folder, and it is just initiated the configuration. But is it created instances with that? So if you go back to that instances, do you see that instances? No, still not yet created. Master node and work nodes are not yet created. It is just a created configuration which is required for the cluster. But then what do we need to do that? Yeah, so list clusters. If you like to see that list of all the cluster information, yes, you can see this command. So the cluster information it is given that here there is a cluster and on the cloud AWS, and there are the zones which are using. It is just information. And if you like to edit the cluster, yes, you can edit it and you can customize the properties. But it is not done. What you need to do finally configure about your cluster with this command is going to helpful that finally to create a resources using the configuration which is done here. So actually Kops update cluster is going to helpful to create a cluster, to create all the resources of the cluster. Let's run this command. Now it takes like around the 5 to 10 minutes on the base of the network bandwidth. All these, yeah, the resources. Yes, it takes. Yeah, now it is saying that Kops has set about your kubectl context. Yes, there is a context fine, and cluster is starting, and it should be ready in a few minutes. Yes, it takes some time. Then you can go for that validating this cluster. The cluster is ready or not. You can check it. The cluster is ready or not with this command. Let me watch it. The watch -n and 1. This is going to just refreshing the command. I don't want to run it each and every second. If I just run it with watch command, yeah, now it is, you can see that yes, instance groups. One master is going to create it. There's a master node with a T2 small, min and max. Yes, in 1A it is launching that, and two worker nodes it is launching as a two worker nodes with this capacity, and in 1A and 1B. But still the DNS is saying that API service is still not yet ready. It takes some time. So almost the 5 to 10 minutes it is going to take it. If you go back to the AWS console, now if you refresh here, now you see this. Yes, it is starting that instances. Yeah, one is master node, it has been created. This is the master node, and with the T2 small, it is initializing, and two worker nodes, so which are having, I mean, with the DNS names also it is following that. The DNS name and cluster name, give it the same, then you will be having that communication automatically between the master and worker nodes. That's why DNS, private DNS we have created. Yes, these are all now these are all in initial stage. And you see this DNS how it is created is, yeah, the what are the DNS name you have configured, the instance ID fine. Let's go to that. Yeah, the public DNS it is using. Yeah, it takes some time to launch it. So there's a public IP address you can use it. Anyway, we'll come back to that how to connect it and how to use it. This and these are subnets which are using US East 1A. This master has been launched, and but anyway, this one you can verify from here also. Now, if we wait some time, then automatically the cluster status is going to come back to that healthy and validation is okay. So I have got the steps of it to create a Kubernetes cluster using Kops utility. Yeah, the detailed step by step it has been given, the documentation. You can get it that from here. What is that? Go to about our group RNS DevOps, and here you can find it Kubernetes resources. In that resources, you can get it in the README file. Yeah. Now what we are doing that first we have taken one EC2 instance, already existing one you can take it, or new one you can take it, but Linux AMI CentOS related take it that, got the commands and everything as per that, or you can take it Ubuntu also you can check it. And created one IAM role with administrator privileges and attach it to that EC2 instance. That is the first step. Then we are installing the Kops and we are verifying the Kops version. And then kubectl we have installed and we are verifying that kubectl, but kubectl before it was showing only client version, server version was failing that. Now we have created the cluster. Once cluster is up and running, then we'll check it that kubectl version whether it is able to connect it to the cluster or not. That is one thing which we need to verify from the kubectl, right? Yeah, and then we have created S3 bucket to store the complete cluster state of the cluster. Yeah, cluster state within that S3. Yes, and we have created one private DNS as to have that all the cluster nodes using the same DNS name as a health checkups point of view, node detections point of view. Yes, instead of having that, instead of depending on IP addresses, DNS resolver is recommended. Clusters point of view. This point of view, one the DNS host zone we have created with the cluster name, and we have attached to that VPC where we are creating about our Kubernetes cluster. And then cluster name and state store. Yes, we have defined some environment variables within the bash RC, and we have created that public and private key. Yes, the Kops is going to use it this public key to copy to all the worker nodes to have the communication automatically. And we have defined the properties which are required. That means state where do you want to store it, how many worker nodes, what is the size of the master capacity, what is the size of that node system capacity, and in which availability zones do you want to launch the instances, what is the name of this cluster, and DNS, yes, is the private one, and how many master nodes that do you need it, with all the properties we have defined the cluster. And then it is just created the configuration within the S3, but it is not created actual resources. But if we need it, yes, update cluster with yes, that is actually creating the resources. And now we are validating whether the cluster is ready or not. Let's wait some time. So up to getting that healthy. Cluster still validation failed, cluster not at healthy. But you see this, yes, DN, I mean, nodes, it is trying to create it. Yes, the 3 nodes total. Yeah, so 3 nodes now it is doing, and master has come to ready, and one worker node also has come to the ready, and one more worker node also has to come to ready. Then the cluster is ready. Yes, now the cluster state is ready. And it is created 3 groups internally to manage it. As ASG groups, it is creating internally. Even one node got failed, another node it is going to replace that. As we know that like ASG groups, there are 3 groups, and yeah, so this is like a master node. This node is ready, true, and 2 worker nodes, yes, those 2 are ready. Then it is saying that about your cluster is ready. Now let's check it kubectl. So what is the command we were using here? Just I was watching this validate this cluster with watch hyphen n1. N1 is nothing but number of seconds that you want to refresh the command. Automatically it is going to refresh it. You don't need to command, I mean, you don't need to run the command each and every time whether Kops cluster is ready or not, like this. So that's automatically that will be refreshed. That's point of watch hyphen n1 we have used. Now the cluster is ready. Good. Now let's verify the kubectl. Kubectl, the version, if I just run this, before it was given that only client version 1.21, but now you see that after creating a cluster and cluster is ready, now about our kubectl is able to connect it to the cluster also. Cluster connecting is nothing but API service, right? And what is the version of the Kubernetes cluster if you see? 1.20. Why it has been set up that 1.20? Actually, the kubectl is showing that client is showing 1.21, but the server version, that's Kubernetes cluster version, is showing that 1.20. Why it is 1.20? So as the Kops which you have installed, Kops is created. Yes, Kops is a created cluster. Kubectl is not creating cluster. Kubectl is a client which is connecting to the cluster. But we have created the cluster with the Kops. Kops, whatever the version we have installed, the same version of the cluster it has been created. Yeah, so that's about understanding how to create it and how do you work with that. Now we have the commands. Next we need to learn some more commands. That is with the kubectl. Now the kubectl comes into the picture to work with the cluster. How many nodes are there in the cluster? How do you know that? All the nodes information? Yes, we have the kubectl get nodes. Now there are the 3 nodes which are there. So it is successfully connected to the cluster, and from the cluster it is getting that within the cluster how many nodes are there. And when these yeah, these are all like um, the names of that, the nodes and the statuses and roles, which one is the worker node, which one is the master node, and when it was started, and what is the version of the cluster which are using. Yeah, this is the command. If you are running that this command successfully, you got it, all the nodes is nothing but about your kubectl has been set up successfully and cluster is up and running. And you can use it some more commands. I will short it commands from Monday. It is just like a basic thing. Cluster info, if you see that, now this is the control plane which is running. This is the main API service. We are saying about it, API is the main service on the master node which is running, right? About our kubectl is always connecting using this URL. This is the API and with the cluster name. The DNS name resolver is helping over here. Yeah, so that's about cluster creation. And if you don't need that cluster, how to delete it? Yeah, anyway, we will start it from the Monday onwards, the firstly to understand out all these next commands. But how to destroy that if we don't need that Kubernetes cluster? That is also important. If you don't destroy it, if that cluster is continuing, master and worker nodes keep on continuing, then it will be charged, which will be small size, right? T2 small we have used. So you can delete a cluster by using Kops delete cluster with the confirmation hyphen hyphen yes. I'm just deleting. I don't need that for the time, but we'll start it from Monday, understanding about the next level. Next, to come up with that, with all these the cluster concepts, is which we should know some application resources. Now, cluster we have set up is nothing but yesterday, whatever the components we discussed, cluster architecture, cluster components, that is we got it now. On the master node and a worker node, those components are ready. But what next? Application side, we need to move it, right? Yeah, so the next we have this application resources understanding. But what about that application resources and how do we use it that? That's which we started freshly from Monday. Yeah, that's next which you can say application resources. Yes, we have like understanding pods and what is the replication controllers and deployment services, scaling features, rolling update. Yeah, there are some concepts which we need to know that. We'll come back one by one all these points.